MS Ramaiah University of Applied Sciences.
Micro-helicopter development. Unmanned aerial vehicles are flying machines that do not carry a human operator and can fly autonomously or be piloted remotely. UAVs are typically expendable or recoverable and can carry a lethal or non-lethal payload. Rotary wing UAVs, such as helicopters, possess the advantage of vertical takeoff and landing capability when compared to fixed wing counterparts. They have higher agility and endurance than multi-rotor UAVs. Techno Center at MSRUAS has been indigenously developing a micro-helicopter for defense surveillance applications. The challenge from the defense community was to develop a micro-helicopter capable of flying to predefined locations specified by GPS coordinates, and all the while flying on autopilot without intervention from the ground. The designed helicopter has a 350 mm rotor diameter, a dimension at which conventional helicopter aerodynamics does not apply. From different types of helicopters in use, single rotor helicopter was chosen for the work. The aircraft design was initiated from a conceptual design stage, wherein calculations were carried out. The micro-air vehicle and conceptual chassis designs were arrived at. Appropriate chassis model was selected from the various conceptual designs for the detailed design, along with expandable chassis and camera mount option. Conceptual design was followed by finite element analysis, modal analysis, stress analysis, and impact analysis of helicopter. One of the first design decisions made was to use electric propulsion because of its simplicity. As in all aircraft, weight is critical to design. So a list of all components was made in order to get a good estimate of weight. Hovering is one of the critical requirements, and this is largely decided by induced power. The disk loading is therefore the next item to be considered when designing a rotor system. Once a list of components was identified, a crude, idealized box-type aircraft with appropriate weights and location was designed for initial modal analysis. A series of iterations guided by stress values was carried out before the final structure was frozen. The first design was for a 650 mm helicopter, and once this was accomplished, the bigger challenge for a smaller helicopter was taken up. Several experimental setups were designed to measure rotor thrust and torque vibration spectrum, among others. Final configuration was successfully test flown and shown to meet the specifications as defined by the customer.
At MSRUAS, we spark your imagination unlike any other.